we assign the floor dead load for the flow finish, sunken, lift, machine load, okay, overhead water tank load. I don't know. So we have assigned the live load also. Okay, we have assigned the load on beams, that is wall load, the brick load we have assigned. Okay, so we have assigned earthquake load also, static earthquake. Okay, we have assigned wind load also, and we have introduced like stiffness modifiers uh, for beam, for wall. Okay, for column, then for slab also. Okay, we have assigned end release, we have assigned slab diaphragm, we have merged the divided frames, okay, and we have assigned auto mesh for walls and floors, okay. And then after that, we have introduced like a response spectrum analysis, and like we have added the load combination. So So after that, we have assigned the like fixed support at the base. Then we check the warnings in the model. Then we have run analysis. Then we'll. So you have to always match the base shear. Okay, before going further after analysis. So it's a concrete. Then we have done concrete frame design. Okay, there was no shear wall, so that's why we have not assigned any peer label or we have not done any shear wall design. So right now, so what we will do, we will perform the stability checks. So please make sure before performing the stability checks, okay, so you have, so the static and dynamic earthquake forces are, it should be nearly equal. So you have to match the base shear, okay. So it's done. I think it's like for see, if you want to see the base shear, you have to go to the display, show table. Then it will be structure output base reaction, and you have to click base reaction and OK. So here you can see the base reaction in x direction is matching with the response spectrum. Also, it's matching with the, I think it's matching with y. Okay, it's matching in y also, or it's matching in z also. So the okay. So the first stability check, so that is maximum deflection in slab should not be more than span divided by 350 or 20 whichever is less. Okay. So we'll go to the plan and length apply. Okay. And I think so. Okay. Okay. So there will be no slabs at the plinth level, and we will check for the first floor slabs. So it will be the shorter span. Okay, shorter span divided by 350 or 20 whichever is less. So we will calculate that. Okay, so we will check this in dead load plus live load. Okay, so slab will be affected by just by dead load and live load only. Okay, so to check the deflection, we will go to show deform shape. Okay, and then here we will select here we will select combination. No. I think it's a moment. Okay. Yes. So we will select combo and then we will select dead load plus live load. Okay, and then we will select draw contour objects. Okay, displacement in Z direction we will check and we will apply it. So you can see at the left bottom, the maximum deflection is 0.4. So the maximum is 0.405 and minimum is minus 10.219. Okay. So minus means it's in the downward direction, or plus means it's in the upward direction. So upward direction is nearly zero, and the downward direction it's a maximum one, and it's a minus 10.291. It is at 8.6875 x x direction, and 9.35443 it's in y direction, or 19.75 it's in uh, I think it's a height. 9.75 is height, and you can see here at this location. So you can see if I move my cursor, the x and y direction will change, and z it's 5.15 here. So you can see in the plan view z is 5.15. So we will go to 19.75. Go to plan and go to the overhead water tank and apply. You can see it's 19.75, and here if I put my if you will hover over the cursor here, so you can see uz is minus 10.219. So deflection slab is minus 10, the maximum deflection. So always check the maximum deflection. So here the span direction, so let me draw dimension line. So the here the shorter span is 3.53. So 3.53 multiply with 1000, then it will be in mm, and divide by 350. Span divided by 350, so it is 10.085. So what code is showing, IS 456-2000, what code is showing maximum deflection in slab should not be more than span bay at 350 or 20 mm, whichever is less. So it's telling us that 10 or 20 mm, whichever is less. So 10 will be less. So the maximum limit will be 10, 10.085. Or we are getting deflection, it's 10.219. So it is exceeding the permissible limit. So what we will do, we will increase the depth, increase the size of the slab. Okay, so let's increase the size. So to do the changes in the model, you have to unlock the model first. Okay, select the slab, go to the assign shell slab section. Here you have to modify it and add a copy of property. Let's take it slab 150, and here take it 150. Okay, and okay, and it should be okay. Let's modify it again. It should be M25, and okay, and okay, and you have to apply it. And now you can see it's slab 150, and below slab is 125. Okay, both the slab 125. So again, what we will do, we will analyze the model. Let's analyze the model. So we'll go to plan overhead water tank and apply it. So you can see the You can see in the downward direction, the maximum deflection is now 7.005, 8.68, 9.35, or 19.75. So it's 19.75, and here you can see it's 8.6, 9.15, and here it's 8.65, 9.35, and at height 19.75, it's -7 only. So now it's under the permissible limit. So now you can see just by increasing the depth, the deflection will decrease automatically. Okay. So suppose your deflection in the slab is exceeding the permissible limit. Just you have to increase the depth. Here you can see this is now we are getting only, you can see 7. Okay, so that's how you have to check for every slab. So for this slab it's 7. Okay, so it's shorter span is same. So here you can see we are getting 4, we are getting only 5. Okay, so here you can see we are getting 4. Okay, the maximum deflection is we are getting 3. So no need to check here. Okay, so if we are getting 3, 5, it it's very less. 4, only 4. Okay, it's only 4. It's only 2, -2, 3. Okay. So this was our first check, that is for slab only. Now second check is R for earthquake, the maximum displacement of building due to, okay, it's for wind only. Okay, so maximum displacement of building due to wind load should not be more than h divided by 500. So we will calculate it. So the maximum height of the building for the wind we will take it is 19.75. So we will calculate it, 19.75 divided by 500. Okay, it will be around, so it's 39.5 mm. Okay, so if you want to check the maximum displacement, that is maximum lateral displacement of the building, okay, due to the wind load. So we will check the lateral displacement. To check the lateral displacement, you just have to go to the display story plot, story response plot. Okay, so here you can see you have selected maximum story displacement. Okay, and the case load we will take it wind load in x direction. Okay, and here you can see we are getting maximum 16.91 only, or that is where that is at. Okay, so that is at, I think, at terrace. No, not at terrace. It's 416 here, and it's almost, okay. So it is, that is overhead water tank. Okay, so at the overhead water tank we are getting 16.91 displacement. That is lateral displacement. Okay, so it's under permissible limit. You can see it's the maximum limit is 39, and we are getting 16.9. So it's under permissible limit. So what I want to teach you right now, let me give you the brief brief about that. Okay, what I'm trying to teach you. So this is our building. It is fixed at the ground, at the base level. Okay, so this is we have applied wind load like this. So there will be a deflection due to the lateral load. Okay. So the deflection. 1 minute. There will be always a deflection. Okay. So the maximum deflection will be at the top story. So we have to check that only. Okay. We have to check the maximum displacement. Here you can see the maximum displacement at the top story. Okay. So due to the wind, there will be lateral deflection. The criteria for the permissible lateral deflection is this as per code 16700. Okay. So now maximum displacement of building due to earthquake load should not be more than h divided by 250. Okay. So so here we have checked in the x direction. So let's check in the y direction also. Okay. So in y direction, you can see we are getting 17.67. So it's also under permissible limit. Okay. So if you want to check the lateral deflection in model, so what we can do, we can check the lateral deflection also in the model. So you have to go to the deform shape. Let's go to the combination. Okay, so what you can do, you can check in the cases also. So check the case wind wx, wind load in x direction, and displacement in x direction. Here you can select and apply. So here you can see, so your building will displace in x direction, you can see like this. Okay. And here the deflection is around in x direction it's 12.05. Okay, so here at the mumpty level, okay, mumpty level, check at the mumpty level. So it's around 15.91. Okay, at this level, and it's 16.91 here. So you can see it's 16.91 at this point. Okay, so you can check like this also, plan. Okay, so here you can see it's 16.917. So in the graph also, the value was same for the x direction. Okay, let's again we will select the wy here. Okay, and apply it. Wy. Okay. Okay, so displacement is in y direction and apply. Okay. It's in x direction. It should be in y direction. Why it's not in y direction? Okay, close it. Okay. 1 minute. Define load pattern. Modify. Okay. Define load pattern. Load cases. Okay. Define load combination. WLXMA. Okay, fine. Define load pattern. Okay, so let's go to I think the let's okay, okay, okay. I think WLX modify. There is no WLX, right? WLY. So what we have to do, we have to change the load combination again. So I will change the load combination. Let me change the load combination for wind. Okay. I think there is some mismatch because of the name. So now, if you will open the load combination, if you open the wind uh, load combination modified, you can see the wind load here also. Okay. So let's delete the temperature load combination. So let's run it again. Why it is in X direction? There's issue, I think. Issue. Displacement in Y, displacement in X. Okay, I think there is a issue in the model. Okay, we will check it again after some time. Mhm. So okay, so the maximum displacement of the building due to earthquake load should not be more than h divided by 250. Okay, so we will calculate it. H is I think H is 19.75. Okay, so 19.75 divided by 250 into 1000. So it's 79. Okay, so permissible limit is 79. So like to check the deflection, so lateral deflection in earthquake. So you have to go to the display story response plot. This is maximum story displacement here, and you have to go to spec X. Okay, and here you can see the maximum displacement in X direction. It is 45. Okay, so I think our limit was, it's 79, so it's under permissible limit. Okay, and let's check in Y direction. So it's only 29.47. Okay, so it's also under permissible limit. So we are good to go. So now what we will do, we will check the at here. Okay, we will check the deflection here again for the earthquake. So let's uh, click the spec X displacement as direction and apply. Okay, it's 41, 45. Okay, you can say 45 is there, and in Y direction, that's displacement in Y apply. Okay, so you can see the displacement in Y direction in earthquake. Okay, so it's around 29. Okay, 29 we are getting. So the story drift due to the earthquake load should not be more than 0.004 into story height. Okay, so this is also this is the check you have to this is the stability check. Okay, you have to perform. So like let me tell you the brief about what is the story drift. Okay, so this is our building. Okay, so this is the displacement. This is the deflection curve. So at the each story you will have a deflection. Okay. So the story drift means this is a difference of deflection at the adjacent story. Okay. Suppose there are story this the one story and there is a this is a two story. Okay. So this is a difference of the deflection in the adjacent two story, that will be story displacement, story drift. Okay. And suppose there will be displacement of story 2, difference in both the story, and that will be story drift for this floor. Okay. And so on. So that's how you can calculate the story drift manually also, or you can take story drift from the software. So right now we will check the story drift again from the software. So the limit of the story drift is 0.004. Okay, it's 0.004. So we'll check it. So you have to go to the display, story response plot. Here it should be maximum story drift. Okay, and let's uh, again select the spec X. So here you can see the story maximum story drifted is 0.003. So it's under permissible limit. Okay. So for spec Y, it is again 0.002. So it's also under permissible limit. So you don't have to check it again. So now we will check the first mode of vibration is preferred to be translation with at least 65% of modal mass participation. So to check the modal mass participation, you have to go to the display, show table, uh, modal information, and here the modal mass participating mass ratio, and click OK. And from here you have to calculate. You have to select modal participating mass ratio, and here you can see the first mode it's 1.31. So the time period is 1.311, and ux, so it's a modal participating mass ratio in global x direction, it is 78%. Okay, so it's more than 65%, so it's the this stability check is also okay. I think it's fine. And again, so the second mode of vibration is preferred to be translation with at least 65% of modal mass participation. So this is the second mode. Okay, this is second mode, and the time period for the second mode is 1.908. And second mode, it's in the y direction. You can see it's the modal mass participating mass ratio in global y direction. It's also 77%. So it's also greater than 65%. So it's also okay. And the third mode of vibration, it's preferred to be torsion. Okay, so that's it's it's this is the third mode. The time period for the third mode is 0.958, and you can see we are getting at least 0% mass participation in both the ux or uy. So that's why it's so. And now here we will check the rz. So rz is greater than zero point 0.5. So it means the the third mode is in the torsion. Okay, so this is, let's calculate. So let's see this in the model. Okay, so if you want to let's check the first mode. Here you have to select the mode 1, and yeah, it's, I think it's okay. No, not, don't draw contours. Okay, and apply it. So you can see, and you can animate this. So you can see the first mode is in it's a translation in X direction, and let's check the second mode and apply and start animation. So you can see the second mode is in the it's also translation and it's in Y direction. Okay, and let's apply here also and start animation. And now let's check the third mode, okay, and apply it. So you can see the third mode is it's pure torsion, okay, and let's okay, pause this. So the first three modes of vibration should contribute at least 65% of total mass, modal mass, okay, in X and Y direction. So we will go to the display show table. We will see the mass participation again. So here you can see its first three mode of vibration should contribute at least 65%. So this is first three, one, two, three, and you have to check here. At the third mode, the sum of the third mode should be greater than 65%. So here it's you can see it's 79 and 77. So it's more than 65%. Okay, and the number of mode to be considered in such a way that at least 90% of the total mass should be achieved in X and Y direction. So here it's saying the last mode should be greater than 90%. The sum of the last mode should be greater than. So here you can see it's 92 and 92. So it's greater than 90%. So that's also okay. Okay. So it's saying that time period of translation mode should be less than 90% of the time period of the above translation mode. So this code is applicable only for the zone 4 or zone 5. So our building is zone 4. So we will go to the display, show table, and okay. So modal mass participation, it's saying that if you multiply 1.311 to the 0.9, so suppose let's do it, okay? Let's do it right now. So 1.311 multiplied with 0.9, so it's 1.1799. So the second mode time period should be less than that. So it's also okay here, okay? So rebar percentage column should not be more than 4%, and should not be less than this. And for beam, it's also 4% and should not be less than. Okay, it's for shear wall. Okay, so now we have performed all the stability checks in our model. So now what we will do, we will go to the plan, first floor apply, okay, and now we will perform the concrete frame design. So here you can see we have designed this. Okay, so let's go to the display beam design. No, not. You can see the verify. So 19 concrete frames are failing the design check. Okay, so we have to check that also. So let's go to here, concrete frame, and display design info and apply. Okay, and go to plan, length apply. Okay, uh, close, and from here we will again verify the all member pass and yes, and then show selected object only. So here you can see, so these beams are failing. Show all. Okay, these beams are failing. Okay, this is also failing. So what we will do, we will change the size of the beam, or we can change the, or we will check it rather the joint is okay or not. Okay, so we have to check that also. So first we will so if you want to change anything in the model, you have to save as. Always save as the model and keep the track of the previous record also. Okay, every time you have to do that. So N02 and save it. So I think let's go to the select the all story at the right bottom and select these two beams and join it. Okay, now I think it's perfect. So for these two beam, what we will do? Okay, these two beams are failing. Okay, so you know why these two beams are failing? Because of it's in between two strong columns. You can see. So that's why it's failing. So what you can do, you can increase the size. That's what we can do here right now. There is no other option. Or you can remove these two columns. So what we will do here, let's remove the column. Delete it and we will select the beam and we will assign the end release. So assign the end release here also. Okay, so go to frame and partial fixed, apply, and select this one and apply and okay, fine. And let's select this and join it. Let's select this and join it. Okay, so I think its beam is 230 by 450. So you have to increase the depth because the length is very high. So select these two beams and go to the define section property, frame section, and select this and add copy of property and be 230 by 550, and let's it should be depth should be 550 and it's M25 and okay and okay. And we will assign it. Go to the assign frame section property and select this and apply. So you can see it's 230 by 550 and it's 230 by 450. So let's do the analysis again. So if you are changing anything in the model, you have to cross check the stability, all the stability checks again. Okay, so there will be a changes in the stability checks if you are changing anything in the model. So here you can see the deflection is 11 mm. Okay, so it is in 19.75. 19.75. It's 11.85. It's 11 here, okay, and it's 10.37 here. 10, it's 10, okay, and it's 8 is here. That is okay. So what you can do, you can increase the size of the slab here, okay, and here what you can do. Okay, 1 minute. So don't do right now. Okay, so we will let's do the concrete frame design. So, all the serviceability checks, the deflection, okay, all the deflection and serviceability checks we will perform in the service model. This is the strength model. So we won't perform the stability checks in the strength model. We have to develop a service model for that. Okay, so let's check it. Verify all member pass. So you can see here only one concrete frame is failing. So let's click yes and show selected object only. So here you can see if that is only one beam is failing in shear only. Okay. So show all and plan and go to the length, apply, and let's go okay here. So it's failing here. Okay, it's you can see. So what you can do, you can save as the file again. N02, it should be N03, and save. And you have to select this. Okay, okay, 1 minute. Let me check one thing. Okay, so it is failing in. Okay, fine. So you can increase the size. Okay, if it's failing, you can increase the size. That's what you can do. So uh, select the all story, select the beam size, and you can go to the frame section properties. And what you can do, you can add a copy of property and increase the depth by 50 mm. Okay, just by 50 mm. It should be 500 b 230 by 500 m25, and okay, and okay, and you can select the beam and you can assign the beam size 500 and apply, and okay, and it should be 3D, and okay, fine, and analyze it. Mhm. So now we will design it again. So let's check it again. You can see two concrete frames are failed in the design check. Okay. Let's check it again. Okay, now two beams are failing in shear. Okay. So I think what you can do. So assign all story and you can assign it beam frame section property. Then you can assign this one and apply OK, and again run analysis. and you can design it. Okay, so it's failing again. Okay, so what you can do? So if it's failing, then it there will be a issue with the, I think, end release. Let's select the end release. So if we are changing the beam depth here, okay, so let's do it here also, okay, and we will assign it frame. We will assign it frame section property, apply, and run it again. So again, it's failing here. Okay, we will see in which load combination it is failing. It is failing in spec Z, EQI spec Z. Okay, it's failing in shear only. So if there is a one option. So what you can do, you can change the size again, or I think it's a property modified 0.01. Okay, and okay. So here there is a no, it's okay. Let's check it. Visible joint. The joints are fine. Everything is fine. I think it's 213 to 500. Property modifier, auto and auto connectivity. Yes. Okay, so I think one thing we are missing. We are missing one thing. Okay, so I think there is only one frame is failing. One concrete frame is failing. So what we are missing, I think. So let's check it again. Okay, so go to the display, show table, and let's check it the let's check the base reactions. Okay, so here you can see. Okay, so it's not matching here. Base reactions are not matching. Okay, so let's match the base reactions first. Spec Z is okay. It's not matching exactly. So if you have changed something in the model, you have to match the base reaction every time. Okay. Mhm. It's EQY spec Z. Copy it and paste here. Okay, it's 0005. Done, and go to the define load case spec X modify spec Z modify 0.675. So let's modify it and copy this and paste here, and then copy this one and paste at this location, and okay, let's copy this one again and paste here, and copy again this copy this one, copy it and paste it at this location, and same you have to do it for rest. Copy this and paste here. Okay, so what? Okay, there is an issue. Okay, why? In spec Z. Okay. Okay, that's why it's failing. Okay, there is a issue. Okay, click OK, click OK, okay, and this define load pattern EQZ modify 5 1. Everything is perfect. Mm, I think run it again. So let load case modify this. Let's put 1,000 here. Okay, okay, and okay, and okay, and run it again. And go to display, show table, click OK. Let's see the base reaction. EQX, EQY. So EQX is matching with the spec X. EQY is matching with the spec Y, but EQZ is not matching with. Okay, so let's copy it again. Let's paste here. Okay, I think let's copy this and done it. Define load combination, not load. Define load cases and Z modify it and paste here, and okay, and okay, okay, and run it. Okay, so go to the display, show table. Okay, okay, you can see it's now it's matching with the spec Z. Okay, and click done, and now we will design it. Okay, why it's failing? Okay, something is wrong actually. I don't know what happened. Okay, let's go to the define load cases and modify the mode, and let's take it 50 and okay and run it again. And क्या हो रहा है? Let's go to display show table. Okay, and you can see okay it's now it is okay. Now let's copy this and paste here. Okay, so now it's perfect. Copy it, done. Go to define, go to the load cases, modify the spec Z and paste here. And okay, and run it again. Go to display show table. Okay, now it's totally fine. Okay, so EQX is matching with the okay, it's not matching. Okay, it's not matching. Okay, fine. We have to do it again. Fine, load cases, modify it. Okay, you have to copy this, and paste here. Okay, and okay, and run it again. Go to display, show table, click OK. So EQX spec X. Okay, it's not matching. Why it's not matching? Copy it again and paste here. So this is the final you got. Okay, fine. Hmm. Copy this. Define load cases. Modify it. Paste. 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 Copy this. Paste here. Okay. Modify this. Uh, copy this and paste here. Okay and okay and run it again. I think finally we got the base reactions. So here you can see EQX is matching with the spec X. Okay, it's okay. Let's assume it's matching. Okay, it's not much difference. Here EQY and spec X, it's 583. Okay, it's why it's not matching. So let's copy it again. Okay, final. Let's do it. Let's do the final. Uh, okay, let's paste it here. Okay, the result is You can see it's fine. It's also okay and it's also okay. Okay, done. Let's go to the fine load case and modify it. Let's copy this and paste here. Let's modify this, copy this and paste here, and okay, okay, and run it. Display show table. Okay, it's 25610, right? Define load cases, spec, modify. 25610. It's correct, right? It's 23692. It's 23692. 23692. Cancel. Display show table. So what? So in Y it is matching, in Z it is matching, but in X it's not matching. So what we will do, we will just copy this and paste here. Okay. So what we will do here, we will do it manually. Okay, I think there will be some issue. So let's uh 629.43 divided by 574.2242 and multiplied with load cases spec modified. So your what you can do, you can multiply it with this one, this copy and paste. It's 28072. Okay, and okay, and okay, and okay, and run it again. And go to display show table and okay. Okay, now so EQX is matching with the spec X. Okay, EQY is matching with the spec Y, and EQZ is matching with the spec Z. And let's do the concrete frame design. Okay, fine. So let's go to plan. Okay, so let's check it. All okay. So all concrete frames are passing the design check. So we have designed the this beam successfully. Okay. Display show table. Okay, it's time period. Fine. So suppose if any column is failing or beam is failing, you can increase the beam depth. Okay, you can increase the beam depth. You can increase the column size if if the column is failing. Or I will take one class in which I will show you how you can design the beams and column before that. Okay, before preparing the framing, you can design the column, you can design the beam, and then you can check in the software. So you can design manually also. First we will design manually and then we will compare the results with the software. Okay, so I think in the next session we will do that. Definitely, we will do that in the next session. And like, if you have any question, you can ask me right now.